Hello students. So let's start today with the lesson limits and derivatives. Okay. So what do you mean by a limit? You have seen this many times. Okay. You must have seen this in questions of standard 12 or in physics. Okay. Limit. So what do you mean by a limit? Now if you take say example limit x tends to 0, f of x is equal to 0. What do you mean by this? It means that now x is approaching 0, then the value of fx becomes 0. Approaching 0 means here 0 is there. So we are approaching from the left hand side and approaching from the right hand side. Not exactly equal to 0. Okay. That is the value can be 0. This is 1. This is minus 1. Right. So this will be negative and this will be positive 0.1, 0.2 and so on. For here it will be minus 0.1, minus 0.2 and so on. So we are approaching 0 such that this fx becomes equal to 0. That is the value of fx becomes equal to 0. Okay. This is called limit. Now to be read as limit of fx as x tends to 0 equals 0. So the limit of fx as x tends to 0 is to be thought of as the value fx should assume at x equal to 0. Okay. Now there are two limits, that is left hand limit and right hand limit. So limit as x tends to 10. So how do we write left hand limit? Okay. Limit as say some x tending to a minus. Okay, you don't have to take the value negative. Only we write that we are approaching from the left hand side. That is why we are writing a minus sign here. Okay, fx is the expected value of f at x equal to a. Okay, given the value of f near x to the left of a. This value is called a left hand limit of a. Same way we write the right hand limit. So limit as x tends to a plus. Okay. So is the expected value of f at x equal to a given the values of f near x to the right of a. This value is called a right hand limit of fx at a. Okay. Now if the right hand and left hand limit coincide, okay, we call that common value as the limit of f of x at x equal to a. And we denote it by limit as x tends to a f of x. Okay. So this left hand limit becomes right hand limit. That time we write this as limit as x tends to a f of x. Okay. Let's see some examples. So example 1. Limit as x tends to 1. So x square plus 2x plus 3. Okay. So here I am going to put 1. That is this method becomes your direct substitution method. Okay. So I'll put here 1, 3. So this is 6. Okay. So there are certain methods for evaluation. There is a direct first one is our direct substitution. Okay. Now sometimes after direct substitution you get fx as of this type like 0 by 0, infinity by infinity, or some a by 0. Okay, this is your infinity. Okay, if you get this type of result, okay, then you have to go for First thing, factorization. Okay, or you can go for rationalization if some root terms are given. Okay, or you can use some standard methods like limit as x tends to a, x minus a raised to n upon x raised to n minus a raised to n upon x minus a equal to n a raised to n minus. Okay, and there is one more method also that we'll see later. Okay, so we'll see these methods one by one. So direct substitution we have seen. We'll go for second method. Example, limit as x tends to 2 x square minus 4 upon x minus 2. Okay, now if you substitute here 2 directly, what you will get? 4 minus 4 upon 2 minus 2. That is of 0 by 0 form. So this is not defined, correct? So we have to use some other method. We can factorize this. Okay, this is of the form a square minus b square. So we can write this as limit as x tends to 2 a square x minus 2 x plus 2. This is a square minus b square. So a minus b, a plus b. That formula you have to use. Algebraic identity. Okay, so this gets cancelled. So when now you can substitute 2 here. So the answer is 4. Okay. Limit is x tends to 1, x square minus 1 upon x minus 1. So here also if you see, you will get, when you put 1, you will get 0 by 0 form, which is not defined. Okay. So we have to reduce this. To reduce this, we have to factorize. Again same formula, x minus 1, x plus 1 on x minus 1. So we'll get 1 plus 1, 2. Okay. Next is we are going to use the standard result. Okay. Limit as x tends to a, x raised to n minus a raised to n upon x minus a is equal to n a raised to n minus 1. This result we are going to use. Okay. So we have the question, limit is x tends to 2 x raised to 5 minus 32 upon x minus 2. Okay. So this is of the form this x raised to n, right? And here 2 is given. So this you have to check whether you get 2 raised to 5 32 or not. So we get x raised to, that is 2 raised to 5 32. So we can make use of this result. Okay. So what is our n here? 5. A is 2. N minus 1. 5 minus 1, 4. Okay. 16 fives are. Okay. So you'll get 16 fives are. Yes. 80. Okay. So this is the answer. So looking at this, we will understand that this is 3 cube, correct? Okay, first you have to write. This is of the form, if you put 3, this will become 0 by 0, which is not defined. And then we are not getting the value. That's why we are going for another method, that is using this 3 cube. Okay. So this is n is 3, a is also 3, 3 minus 1 2, 9 3s are 27. Okay. Next question. Limit as x tends to 2, 3x square minus x minus 10 upon x square minus 4. Okay. First you substitute directly 2. So this becomes 4 3s are 12 minus 2 minus 10 upon 2 square 4 minus 4. So this is of the form 0 by 0, which is not defined. Okay. So we have to go for some method. So here you can factorize, that is, this is quadratic equation, correct? So you can find the sum and the product, so you can factorize. So product is minus 10, sum is not minus 10, minus 30, sum is minus 1. So 6 5s are minus 6 plus 5. Okay. 3x square minus 6x plus 5x minus 10 upon x square minus 4. Again you can reduce this. A square minus b square formula. So this is 2 square. X minus 2, x plus 2. Please go through all the formulas, that is algebraic identities. Okay. Also you have to revise trigonometric identities also, because here also there are some problems based on trigonometric identities. This is, so taking common 3x x minus 2 plus 5 . Okay. So you will get 3x plus 5 x minus 2. Okay. So you will get 3x plus 5 upon x plus 2. Now you can substitute 2 here. It is a 6. 6 plus 5, 11 upon 4. This is the answer. Okay. Now here, this is quadratic and this is cubic. Okay. First you put value 2. Okay. Let's see what we get. 4 minus 2 minus 6 upon 4 to cube. 8 plus 4 plus 1. So we are getting minus 2 minus 2. We are getting a positive values. There must be some mistake here. Next question. So here your term in the numerator is x raised to 4. Okay. In the denominator it is x square minus 1. First you have to put the value of 1. So 1 minus 3 plus 2 upon 1 minus 1. So this becomes 0 by 0 form, not defined. So we have to reduce this. Okay. We can find factors of this term, that is, this is a square minus b square form. Okay. This we have to reduce by using synthetic division. Okay. or you can divide. That is, you have to do the division algorithm. Okay. So this I'll write 2 upon x minus 1, x plus 1. Okay. So either we'll get a factor as 1 or minus 1. Okay. Let's do synthetic division. I've done one video on synthetic division. You can go through it. So synthetic division, you have to go for the coefficients. Now x raised to 4 has 1. Here there is no x cube term, so 0. X square term is also not there. X term has coefficient minus 3 and last one is 2. Okay. Now I'll take 1 as the factor. So 1, this one comes here. 1 into 1, 1. 0 plus 1, 1. 1 into 1, 1. 1 into 1, 1. So this is minus 2. 1 into minus 2 is minus 2. So 0. Okay. So we are getting x cube plus x square plus x minus 2. Okay. And this is our x minus 1. That is x equal to 1 we had taken. So it becomes x minus 1. So we can write this as limit as x tends to 1, x minus 1 into x cube plus x square plus x minus 2. Okay, now we can reduce this. So now if you put 1 here, you will get 1 plus 1 plus 1, 3. 3 minus 2 is 1. 1 plus 1 is half. Okay, this is the limit. So you have to reduce it. Next question. Here both numerator and denominator has same degrees. Okay, so for both we have to use synthetic division to reduce them. First you put x equal to 1. So 3 minus 1 minus 2 upon 1 minus 3 plus 2. So this is 0 by 0, not defined. Okay. Now reducing both. Now which factor we have to take? So whenever you are giving a limit, given limit, x tends to 1 or x tends to 2. Okay. So start with that number first. It can be anything, but start with that number. Then you can increase 2 or minus 1 you can take. Okay. So starting with 1. So I'll take first the numerator. So it is 3, x cube is 0, x square 0. For x it is minus 1. For this constant term is minus 2. So this 3 comes here. 1 into 3, 3, 0 plus 3 is 3. Again 3, 3. 1 into 3 is 3. This 2, 2, 0. Okay. So we are getting x minus 1 into x cube, 3x cube. Okay, I'll write here. X minus 1, 3x cube plus 3x square plus 3x plus 2. Okay. Now we'll reduce the denominator term. Again taking 1. So here the coefficient is 1, 0, 0, minus 3, 2. And 1, minus 2, 0. Okay. X cube, x square, x minus 2. So we can cut this x minus 1, x minus 1. So now you can put 1. So you'll get 3 plus 3 plus 3 plus 2 upon 1 plus 1 plus 1 minus 2. Okay. 9, 11, 3 minus 2, 1. So answer is 11. Okay. Next question, limit as x tends to 1, 1 upon x minus 1 plus 2 upon x square minus 4x plus 3. So first you put x equal to 1, so we'll get 1 upon 0 plus 2 upon 1 minus 4 plus 3, also 0. So this is of not defined type. Okay, so we can write this as 1 upon, we can reduce here. That is, this is quadratic equation. So factorize 3 minus 4. So we'll get 3 ones are 3. Sign of the minus 3 minus 1. So x square minus 3x minus 1x plus 3. X minus 3 minus 1 x minus 3. So x minus 1 and x minus 3. Okay. So now if you cross multiply, you will get or you can do one thing, that is I can take common x minus 1. Okay. So the remaining thing is 1 plus 2 upon x minus 3. So here you can cross multiply. So I'll write x minus 3 plus 2 upon x minus 2. Okay. So x minus 3 plus 2 is minus 1. So this term and this term gets cancelled and we will get here 1 upon 1 minus 3 minus half. Okay. So we have algebra of limits, that is sum, addition, limit as x tends to a, f of x plus g of x. So we'll get limit as x tends to a, f of x plus limit as x tends to a, g of x. Okay. Then similarly it is for plus or minus. Okay. Then multiplication, it is, we can take limit f of x into g of x. Okay. Same way it is for division. Only thing is this g of x should not be equal to 0. Okay, this is algebra of limits. Then we can take a scalar multiple also, lambda outside. So that lambda we can take outside of that limit. Okay, if it is not a function of x, then we can take it as some constant. Let's do some examples on rationalization. That is, if you are given a term with root, okay, so say limit as x tends to 3, root of x plus 6 upon x square minus 9 minus 3. So if you substitute here 3, so this becomes root of 9. So 3 minus 3 upon 0. So 0 by 0. Not defined, correct? So we have to rationalize this. We have to multiply by x square minus 9, we can write x minus 3, x plus. Okay. Now rationalizing term. That is, you have to take x plus 6 plus 3 in the numerator and in the denominator. It is outside of that root. So here using again a minus b, a plus b. So a square root square minus 3 square upon this denominator. Okay. So this thing becomes x plus 6 and this is our 9. So 6 minus 9 minus 3. So you'll get numerator as x minus 3, which you can cut, and here you have to put 3. Now this is a positive term, so you'll get some number. So you'll get 6, 9, so 3 plus 6, 1 by 36. Yeah.